An object moves with a constant speed of 10 meters per second for 15 seconds, and we want to know how far it's going to go. All right, so constant speed of 10 meters per second for 15 seconds. How far is that going to go? We've got our kinematics equations here, and we'll start, as always, with givens. So what given information do we have from this problem?
Have the speed?
Yeah, we've got a speed, right? A speed of 10 meters per second. Is that my initial speed, final speed, or something else in this case?
I think it's the final speed.
Okay, it is the final speed, right? But what does it say? It says it moves with a constant speed, right? What does that mean?
Acceleration?
Is it accelerating if it moves with a constant speed?
Oh, no.
No, right? Because constant speed means the speed's not changing, right? So if the speed's not changing, the acceleration has to be what?
The same.
Well, the same, or remember, acceleration is how quickly the speed is changing. Yeah, well, acceleration is how quickly the speed is changing, right? So if the speed's not changing at all, that tells us exactly what the acceleration is. What would the acceleration have to be to make a change, to make no change at all in the velocity?
Zero.
Zero, there it is, yeah. Right, since the speed is constant, then we know that we know acceleration has to be zero, right? And that's because we know acceleration is changing speed. No change, no acceleration.
We have the time too, 15 seconds.
Yeah, great, exactly. We do have the time. That's the other thing we have, 15 seconds. So we've got acceleration, we've got time, we got a speed, and maybe it's initial or maybe it's final, but if we think about it, if the speed's not changing, then it's both, right? If the speed's not changing, then we start at 10 meters per second and we end at 10 meters per second. So I'll put them for both of them. Our initial velocity is 10 meters per second, and our final velocity is also 10 meters per second. So we actually have more givens than we need to do this problem. And all that means is that we'll have a choice. We can pick more than one of the equation, but we'll get the same answer, whatever equation we pick. But before we pick an equation, we need to know what the problem's asking us, right? So what's the unknown for this problem?
The delta x?
Yeah, exactly. How far does it go? Right, we're looking for delta x. Okay, so now we can figure out what equation to use, right? And it's usually we have three givens and one unknown, and that leaves us exactly one equation to use. But we have extra givens, we have extra information here. That means we can use pretty much any of these equations as long as it's got our unknown in it. So we'd be all right using either equation 1 or equation 3 or equation 4. Any preference? Which one is going to be so we might as well pick the easiest one to use, right? If we're looking for delta x, we probably don't want to pick equation 4. We'll have to rearrange it. So we can pick either equation 1 or equation 3. And it really doesn't matter which one we pick. So why don't we pick equation 3? Delta x is Vxi times delta t plus 1/2 ax times delta t squared. I don't need to rearrange it, right? Because I'm looking for delta x and that's already by itself. So I'll go ahead and plug in my numbers. Vxi was 10 meters per second times delta t, 15 seconds, plus, and at this point, right, I know my acceleration is 0. So 1/2 times 0 times anything else, right, that's all going to be 0. Right, because acceleration is 0, so that whole piece is 0. So that means that I don't even need my calculator today because it's just 10 times 15 for my distance, and that's 150. And I've got a meters per second times a second, so the seconds cancel out, and I'm left with meters, and I think that's right because I'm looking for a distance, how far. And if you want to see if the other, I recommend you try using equation 1 as well, and you'll see that you'll get the same answer, 150 meters either way.